The first part of the question is asking us to take a look at the graph and see can we say anything about the circulation and flux. So if you watch the lesson video, we go something like this. The curve R is the circle with a radius of 3, which starts at 3 on the x-axis and goes in the counterclockwise direction. So for circulation, we're trying to get an idea. If we draw a tangent vector here, how does that compare with the field vector? Well, the one I just drew, you can see, is directly opposite. However, there are some tangent vectors, such as the one over here, that line up with the field. And so we want to go around the circle, asking ourselves how many of these line up and how many of them are opposite, how many positives and how many negatives. I'll let you make that decision. Again, that shouldn't guide what you do in your calculations, but give you some confidence in your answer. Now, for the flux, we're going to be taking a look at the circle, and we want to know how many of the arrows from the field are there coming into the circle, and how many are there that are going out of the circle. So again, it's sort of a mental picture. How much in is there? How much out is there? And so again, I'll let you give it a try and see what you come up with. So for our calculations, in the beginning, we need to calculate the circulation. The definition for circulation is the integral over the curve of the field dotted with ds. However, what we normally do, and this is in the lesson video, for working purposes, we generally write this as the integral over the curve of f dot dr, where dr is r prime t dt. So there's our working formula for circulation. So we need to convert our field from x's and y's into t's. So using the 3 cosine t for x and the 3 sine t for y, we'd have x, which is 3 cosine t, and negative y, which is negative 3 sine t. So there's our field in terms of t's. We need the derivative of our curve. So the derivative of 3 cosine t would be negative 3 sine t, and the derivative of 3 sine t would be 3 cosine t. And so our integral is going to go from 0 to 5 pi over 6, and we'll dot f in r prime. So we have 3 cosine t times negative 3 sine t, which is negative 9 sine t cosine t. We have negative 3 sine t times 3 cosine t, which is negative 9 sine t cosine t again. And we can simplify that somewhat into negative 18 sine t cosine t. Now I'm not going to take the time to evaluate this by hand. You could do a substitution that we learned long ago, or you can just type it into your TI-89. That comes out to be a negative 9/4. So in the beginning, did you think that the circulation was going to be a negative? Let me also point out that 9/4 is rather small. So if in the beginning you guessed that it was pretty close to offsetting each other, you would have been correct. So in the next calculation, flux, the definition for flux is we want to do F dot capital N ds. Our working definition for the sort of situation that we have is we do F dot any normal vector dt. And I showed you in the lesson video why that works the way it does. So let's find a normal vector. Now, a normal vector can be found from the tangent vector simply by reversing the two components and doing the opposite of one of them. So we'll take the y component, 3 cosine t, and use that for the x component. We'll take the x component of r prime, negative 3 sine t, change the sign, and make it 3 sine t, and use that for our y component of n. So we have the integral from 0 to 5 pi over 6. The dot product of n and f would be 3 cosine t times 3 cosine t, which is a 9 cosine squared t. And negative 3 sine t times positive 3 sine t, or negative 9 sine squared t. Now to do this integral by hand, you will need to employ identities. Or we could type it into our TI graphing calculator. And so there are the circulation and flux.